Hey guys, so this is the review video for simplifying expressions using the exponent rules, some of the exponent properties that we had observed in class. If you remember, this was the day when we passed around the yellow posters and they each had a bunch of exponent problems like these, and you had to sort of decide, okay, what's happening and what do I see, what patterns do I notice? And so this should be a quick little review just to remind you of how to look at stuff like this and how to simplify these expressions. So first, we're going to talk about if you're multiplying things with the same base. Again, if you recall, the base is the thing being raised to the power. So in this case, in the first problem, x is the base. Your exponents are 6 and 2. And then your coefficients are these things in front. So in this case, it's 5 and 3. Those are your coefficients. X is your base. 2 and 6 are your exponents. And when you're going to simplify these, what you're going to do is you're going to first multiply the coefficients. So multiply 3 and 5, that would give you 15. Then the base is going to stay the same. It'll still be x. And then in this case, again, you're going to add up your exponents because you're multiplying with the same base. That's 8. And if you want to think about it, that means x squared is like x times x. X to the 6th would be x times x times x times x times x times x. 6x's. 6x's and 2 more of them would give you 8 total. So 15x to the 8th power is what I want. In these problems here, the coefficients, there's nothing written in front, but that means that the coefficient here is 1. Alright? That also means that the coefficient is going to be 1 at the end. And we could write it, we could say 1x to the something, but we're not going to. We don't really need to. If you do write it, it's not wrong, but it's not really the best thing. So it's like 1x to the 5 plus 9 14th power. So again, when you're multiplying with the same base, you add the exponents. We also saw sort of the opposite of that. We saw that when you're dividing with the same base, you divide your coefficients and subtract your exponents. So in this case, 6 divided by 2 is 3, and x to the 5th over x cubed. 5 minus 3 would be x squared. And we could pretend this is all like over 1, but again, it's just 3x squared because everything in the numerator is bigger than what's in the denominator. Okay, so all these things are in the numerator. This next one is a little bit different because there's 1x, like x to the 1 at the top. There's x squared at the bottom. So there's 1x at the top and 2x's at the bottom. So that means that there'll be a leftover x, but in the denominator. And in this case, we can think, okay, 4 divided by 12, that's like 1 over 3. And that means that 3 is going to be in the denominator. We just get a 1 in the numerator. Raising an exponential expression to a power, you sort of distribute the exponent on the outside of the parentheses to everything on the inside. Even the coefficient, here the coefficient's 2, but that's like 2 to the 1. So again, when you distribute that, it becomes 2 squared, or 4. And you multiply those exponents, so 2 times 5 would be x to the 10th. Here again, we're going to distribute this thing on the outside because the parentheses are there. What that would mean is that it's like there are 3 x squareds y cubes all together. And it sort of relates back to if you had them all together and you were multiplying them out, you would add the exponents. This is just a shorter way of writing that. So you'd have 3 groups of 2x squareds that would leave you with a total of x to the 6th. And if you had 3 groups of y cubed, that'll give you a total of y to the 9th. Again, things that you should have seen before, just a little bit of review. Negative exponents are a bit different. They're sort of just a manner of writing things. The trick we sort of learned here to deal with them is that when you see a negative exponent, not a negative coefficient, but a negative exponent, you're going to put whatever's the base is in the denominator and make the exponent positive. And in this case, there's no coefficient, or the coefficient is just 1, so we can say it's 1 over x to the 5th. Here, again, the exponent negative 3, it only refers to the y. Y is the base. The coefficient is 2. So the 2 is going to stay in the numerator, but y to the negative 3 can become y cubed in the denominator. Alright. Last thing we said, if there are fractional exponents, there's a way to sort of convert those into radicals. We said that in general, the numerator, so the 1 here, will become the power of the x, and the 5, which is the denominator there, will become what's called the index. Okay, and essentially what's going to happen is that'll turn into this. The index goes up there, you'll have x to the 1, so it'll be like the 5th root of x to the 1. Let me write that a little bit better. Okay. This one, again, same idea. The denominator is going to become the index, so the 3 would go there, and then it would be n squared on the inside. Okay, just a quick little review. You can let me know if you have any questions during review today.